Yeah, you guys were expected to do this last night, along with keep up with the other topics that we're talking about. So I'm gonna go ahead and review the answers, go through it with you. This is Chapter 1 review. So domain, remember, is an X thing. All right, it's your set of X's, and range is your set of Y's. So when we just have points, it's really just a matter of making brackets for your set notation, and it looks like I have -3, 0, 2, 4, and 5 as my X's, and for my range it looks like I have 0, 2, 4, 5, and 2, so I don't have to write the 2 twice. 0, 2, 4, 5. So there's only 4 different Y values. So there's your domain and there's your range. Evaluate. Remember, that's just a plug it in problem. This is a fancy way of writing an equation. This is a function. We're going to evaluate it at 4. So f of 4 is -3 times 4 plus 2. It's simple as that. So -12 plus 2 is -10. Number 3, standard form. There were some particular rules that we had to learn. Standard form looks like this. First of all, the X and Y are on the same side. A, B, and C must be integers, no fractions. So if there are fractions, you have to multiply through by the denominator. And then number 2, A must be positive. All right, so that's not that's kind of a traditional thing, that A must be positive. Some textbooks will leave that out, but we learned it as A must be positive also. So in these two examples, really it's 2 steps for the first one. I need to bring this one over with the Y. How do I do that? Well, here, I'll rewrite it. I subtract 3x from both sides, and I get Y minus 3x equals -2. Basically I just subtracted 3x from both sides, and now I have x and y on the same side, but the x is negative. So how do I get rid of the negative? I multiply by -1, both sides by -1. I can't just do one side. So I get 3x minus y. I'm going to rewrite the x first. So when I distribute this, I'm going to get a positive 3x and a negative y, and then it's going to be a positive 2. So that's in standard form. Okay, imagine that. You're seeing a little shadow there. It's actually sunny in Ohio. Can you believe that, in the middle of the winter? Anyways, here we go. So again, all I have to do is subtract 8y from both sides. That's going to cancel that out. I have 4x minus 8y equals -12. And there aren't any fractions. A is positive. X and y are on the same side. So that's in standard form. And number 4, find the x and y intercepts. Not too difficult. So first of all, this one's in standard form. There was a really easy way using an XY chart that we found the x and y intercept. If you think about it, when I plug in 0 for x, or if I think about the graph, okay, this is where x is equal to 0, the y-axis. Alright, so when I plug in 0 for x, I'm finding the y-intercept. So, we did this right here. We showed our rule, our work here. We did 3 times 0 plus 2y equals 6. Well, guess what? 0 plus 2y is just 2y, and then 2 times 3 makes 6. Or I could think about dividing both sides by 2, so y would have to be 3. So there's the y-intercept. Okay, and then the same token, I can plug in 0 for y. This is the x-axis is where y is equal to 0, if you think about it. So I can do 3x plus 2 times 0 equals 6, so I get 3x equals 6. So x must equal 2 when y is 0. So 1, 2, So that's your y-intercept. That's your x-intercept. Now, this one is set up in slope intercept form. Alright, and so if you remember, you can do the same thing, you do the same token, you can still plug in 0 for y, or 0 for x, and 0 times a half. Say if I do, okay, 0 times a half is 0, minus 8 is negative 8. But you've also learned y equals mx plus b, and we look right there for the y-intercept. So that's my y-intercept. Okay, so how am I going to find the x-intercept? Well, same thing, you can just plug in 0 for y. I know you're not used to doing this very much, but this is not that difficult of an equation to solve. If I plug in 0 for y, I can solve for x and see where my x-intercept is. So let's do that. So I want to get x by itself, so I'm going to add 8 to both sides. And I get 8 equals 1/2 x. And then this is really 0.5, or it's just a number, so divide both sides by 1/2, and 8 divided by half is 16. So that's my x-intercept. So I plug in 0, and you could plug it back in and see if you're right. Half of 16 is 8. 8 minus 8 is 0. So I did it correctly. Okay, number 5. Finding the slope between 2 points. You can use the subscripts 1 and 2, or just as long as you keep it in order. So if I'm going to do this x minus this x, I got to make sure that so if I go the first point minus the second point, I got to make sure when I do my y's, I do the first minus the second. And I get 5 over negative 3. Other thing we've done to make sure and keep our x's and y's straight, an xy chart is nice because it kind of organizes, and it really separates your y's and separates your x's, and you can kind of think about, okay, this went down 5, this went up 3. Alright, the difference between those, looking at how much did y change, how much did x change, things like that. So the change of y is negative 5, and the change of y is negative 5, the change of x is positive 3. It's the same thing, it's still a negative 5/3. Okay, this one I'll do quicker. Slope equals. Remember, another thing people do is they switch y over x, or x's and y's. So you have to do the difference of your y's, which are those two, over the difference. As you can hear my daughter, she wants to play. Negative 3 minus 4 is negative 7. But 0 over anything is 0. Okay, right in slope-intercept form. How many times have we done this year? Point-slope form gets us that. So we do y minus y1 equals m times x minus x1. So we plug these different things in. This is your x, that's your y. Subtracting a negative is going to make that positive. Subtracting a negative is going to make that positive also. Distribute the negative 2. And subtract 5 from both sides. And I have y equals negative 2x minus 11. Alright, this one you have to actually find the slope. Subtract the y's. I'm going to do 9 minus 1. So if I start here and go here, I'm going to have to go 4 minus 6. So that's 8 over negative 2, which is negative 4. Alright, so my slope is negative 4. And my point that I'm going to grab is 6, 1. You can use either one. Alright, but I'm back up here. I'm going to use point slope form. So here we go. Y minus 1 equals negative 4 x minus 6. I used 6 for x, 1 for y. Distribute, add. My final answer. And then we had 4 graphs. So there we go. So this first one's going to be real simple. I have slope of 3, y-intercept of negative 2, and we go from there. So this thing crosses at 2, it goes up 3 and over 1. Remember, slope is a fraction, 3 to 1. So it's positive. So I could go down and left. That would still make the same marker here. So things to check here, make sure you have positive slope. That increases from left to right. Okay, negative slope goes down from left to right. Alright, number 2, or letter B here. You know, most of us are probably going to put this, take the time and put this in slope-intercept form. So to do that, it looks like I have to subtract x from both sides. So now I have 2y equals 6 minus x, and then divide by 2, and y equals 3 minus 1x over 2. So my slope looks like it's negative 1/2, and my y-intercept is 3. So if I come back here, make sure everything's on the screen. Let's use this one. So this crosses at positive 3, and now it has a negative slope. So I'm going to go down and right, and that makes a decreasing line. Down 1, right 2, or up and left also makes a decreasing line. And there we go. Alright, so y is greater than or equal to 2x plus 1. So this is already set up in slope-intercept form, so I know my slope is 2 over 1. My y-intercept equals 1. Now, since it can be equal to, it's going to be a solid line, but we've got to kind of review, sorry about the shadow, if it's just that, if it's just greater than, remember it's going to be dashed. We just kind of had a review of that anyways, but this crosses at 1, it goes up 2 and over 1. Remember, it's increasing, so make sure this thing is going up from left to right. Alright, so it's going to be a solid line. Now, since we have an inequality, we need to shade one way or the other. Now, y is greater than, and we kind of got in the habit of doing above for greater than and below for less than. That's a greater than sign, so we're going to shade above. But really, the technical way to do this is to plug in, you know, a point, which we know that a test point, an easy one to test, is 0, 0. And if I test that, 0 is going to say that 0 is greater than 1. And we obviously know that that's false. Okay, so that was not a solution. So we're going to shade away from that. So just like we did quadratics, if it's false, you're going to shade away from that point. Alright, last one here. So D is x minus 3y is less than 6. So there's a little bit of work to be shown, but not that difficult. Now, some of you might put this, find the intercepts, but 9 times out of 10 you've been taught to put this into y equals. So to do that, I'm going to subtract x from both sides. So I have negative 3y is less than 3 minus x. Then I have to divide by negative 3. And this is what's tricky about this. Since you divided by a negative, you must switch the sign. Alright, we've done this enough, and we have some double negatives going on here. So negative 1 divided by negative 3 is a positive 1/3 x, and then 3 divided by negative 3 is negative 1. So putting that in slope-intercept form is a little bit trickier than you might think. Alright, and don't forget to switch your sign. So once we have that all done, we know it crosses at negative 1, has a positive slope of 1 to 3. So up 1 over 3, or down and back. That's an increasing line. Again, this thing is only greater than, so we must use a dashed line. What that really means is that the points on that line are not solutions for that. Alright, let's see if 0, 0 is a solution. So 0, 0 is right there, it's in the center, and I get the statement that 0 is greater than negative 1. Last time I checked, that's true. 0 is greater than negative 1, so I'm going to shade towards that point. And that should be the end of Chapter 1 review.